Good morning, students. Today we are going to be taking a look at exterior angles and inequalities. An exterior angle. What in the world is an exterior angle? So if we draw a triangle with a ray over here, we can see that all of these angles that are inside the colored in triangle, these are the interior angles of the triangle. Okay, that means that this angle here is the exterior angle of this triangle. So what exactly is an exterior angle? Well, the book gives us the definition, and it says that the exterior angle of a triangle is that angle that forms a linear pair with the angles of the triangle, okay, with one of the angles of the triangle. So this here is my exterior angle. This angle plus this angle would be my linear pair. Okay? So I'm just going to write down right here. Angle ABD plus angle DBC equals 180 degrees. Okay? Because it's a linear pair. All right. So over here we have it again. We have our exterior angle. And then we have our linear pair. But we're also looking at remote interior angles. So what are remote interior angles? Well, the name says they're remote and they're interior. So we're going to be looking at the interior angles of the triangle, or the angles inside the triangle, and they're remote, so they're far away from this angle. So these two angles here that do not make up part of the linear pair would be our remote angles. Okay? So this is our exterior angle. This is the angle of the triangle that makes up the linear pair with the exterior angle. And then these two are the remote interior angles. All right. So we're going to flip the page. And we're going to look at the exterior angle theorem. So the exterior angle theorem, what does that say? It says the measure of an exterior angle of a triangle is equal to the sum of the measures of its two remote interior angles. So what they're saying is that this angle here, XYZ, has the same angle measurement of angle X plus angle W. Okay? Why does that work? Well, they did a proof to help us see why that works. So they gave us this triangle here. Okay, we have angle GHJ as our exterior angle to triangle HIJ. Okay, so, and it tells us in the given that triangle HIJ with the exterior angle JHG. We have to prove that the measure of angle GHG is equal to the measure of angle I plus the measure of angle J. So we're going to start with our given that triangle HIJ along with the interior of angle JHG, that's our given. Well, this is an exterior angle, and we know from the definition of exterior angles that this angle plus this angle here is going to be a linear pair. So we wrote that down, definition of exterior angle. We know that linear pairs are supplementary, so we write that down. Why? Linear pairs are supplementary. If these two are supplementary, then I know if I add them together, it's going to be 180 degrees. How do I know that? Definition of supplementary. I also know that I have triangle HIJ, so that if I add up all of these angles added together will also equal 180 degrees. So that's my next step. How do I know? Measures of a triangle. The measures of the angles of a triangle total 180 degrees. If this is equal to 180 degrees and this is equal to 180 degrees, I can say that they're equal to each other by the transitive property of equality. So that's step 6. I'm looking at this and I see that I have the measure of IHJ on this side of the equal sign, and I also have it on this side of the equal sign. So I can add the negative of that to each side, and that would leave me with the measure of angle JHG equals the measure of angle I plus the measure of angle J. And that's the addition property of equality. Okay, so what that's saying from this proof is that this exterior angle measure is equal to both of these added together. Why does that work? It works because this angle is both part of the linear pair and it is part of the triangle. Let's just pretend that this is 30 degrees right here. If this angle is 30 degrees and a triangle measures 180, what do these two have to equal when added up together? So that would be 180 degrees for the triangle minus the 30 degrees of this angle would mean that these two would have to equal 150 degrees when added together. Okay? Now I have, if I look at the linear pair, and this is 30 degrees, well, I know that a linear pair, when these two angles are added together, equal 180. If this one's 30, say 180 minus 30 is 150. So this angle is 150. So it works even with numbers. So if I have this angle, it is equal to these two angles added together. Okay, and that's how to use the exterior angle theorem. Helps you to find the measurements of some angles. Okay, we're going to be working with inequalities as well. Okay, so we're going to look at these inequality facts. We're going to review them because you guys have already had these. So if we know that A is greater than B, let's say 3 is greater than 2, then we know that A plus C, oops, I'm sorry, that's less than. Let me start over. If A is less than B, then A plus C is less than B plus C. So let's say that A is 2 and B is 3. Okay, we'll say C is 1. So 2 plus 1 is less than 3 plus 1. So 3 is less than 4. That works. Multiplication property. If A is less than B and A is greater than 0, then A times C is less than B times C. So if this is 1, this is 2, and we'll say this is 3. So 1 times 3 is 3, 2 times 3 is 6, 3 is less than 6. If A is less than B and C is less than 0, then A times C is greater than B times C. Say 1, 2, negative 1. All right, so 1 times negative 1 is negative 1, and 2 times negative 1 is negative 2. Negative 1 is greater than negative 2. Okay, so that's how that works. The transitive property. If A is less than B and B is less than C, then A is less than C. We'll do 1, 2, and 3. Okay, if 1 is less than 2 and 2 is less than 3, then 1 is less than 3. Then we have the definition of greater than. If A equals B plus C and C is greater than 0, then A is greater than B. If 3 equals 2 plus 1, then 3 is greater than 2. Okay, and that's how those work. All right, and the last thing we're going to look at is Theorem 711. It's the exterior angle inequality. And it says that the measure of this interior angle is going to be greater than the measure of either this angle or this angle. And if we remember the last theorem we did, we said that if we add these two angles together, it equals this angle. This theorem here says, you know, this angle will be greater than either one of these by itself. Okay, and so here is our proof. They've given us triangle ABC with the exterior angle DAB. And it says that the measure of angle DAB, we have to prove that the measure of angle DAB is greater than the measure of angle B. And we have to prove that the measure of DAB is greater than the measure of angle C. So how are they doing that? First, we start off with our given. We were given the triangle and the exterior angle. That's given. The exterior angle theorem tells us, well, because we have an exterior angle, so we go to the exterior angle theorem. we proved it on the last page, so we can use it in our proof because it has been proven. The exterior angle theorem says that the measure of angle DAB equals the measure of angle B plus the measure of angle C. If DAB equals these two added together, then we know that DAB has to be greater than angle B, but it also has to be greater than angle C. So that's what we did here. The measure of angle DAB is greater than the measure of angle B with the definition of greater than. It's greater than angle C by the definition of greater than. All right, and that's it for this chapter. We'll do some exercises together, and if you guys have any questions, I'll take those questions and we'll get things figured out.